I'm very happy to be here again at Amsterdam .NET Group for this event, Global Azure. And I have the pleasure to talk about one of my favorite topics. It's semantic kernel, because why not? As a .NET developer, we have the right to get a big chunk of AI as well, right? And even if this framework is designed for more languages, so if you are Python or Java developer, you can as well use semantic kernel. Today, I will focus on what I know best, it's .NET. But keep in mind, you can do the same thing, more or less, yeah, because they are not quite synchronized, or not all the features are aligned with all these frameworks, but more or less you can do the same thing. So I'll go quick over this. Maybe you had a chance to work with ChatGPT, maybe with GPT API, maybe with some other open source models as well. But nevertheless, I want to emphasize on the importance of this area of AI, which has now very good traction and opens new opportunities to solve new family of problems. So, yeah, AI is the larger term, but then it's generative AI, subgroup of deep learning, and then it's large language models with the implementations of OpenAI, such called like GPT. Okay, and now we reach to the point where we touch the specific of this topic. First, before explaining a little bit what is OpenAI Assistants, I want to remind you about function calling. This was a feature which I have to admit was not so visible to me, but it was there for this last summer. So why I will talk about this a little bit? Because we will notice some features which are now used in assistants were there already in function calling. So if you have the chance to work with the semantic kernel, you may have noticed there are a lot of features. So you can write code to orchestrate AI, and for that you have the possibility to develop or to declare your own functions, semantic or native, and to put them in plugins, which are pretty much like containers, to organize them together for the same purpose. So along with these plugins, which is not so exotic, let's say, then there are the planners. And the planners is for you to build a plan. And let me give you an example. If you are solving a classic problem, we, as developers, we are so into solving the problem by putting there the step-by-step logic. So we build the logic, we put there the steps, we run it. But why not to use AI to help us with the step? Let AI do the steps. I mean, to figure out the steps how to solve a problem on our behalf, of course. So planners are such constructs which allow us to delegate to GPT these steps to solve a problem. And here, this comes with the cost. We know already the GPT is non-deterministic. And this is a sin from our perspective. How can we cannot replicate anything? We cannot rely on anything. Even if we have some mechanisms to keep the things in place. Now I'm referring the seed parameter, which is quite new in GPT, to force a little bit of, to force the model to not be so creative, because we don't like when we want to test. Still, inside the model, there are some mechanisms, some algorithms which are having this randomness, so we cannot rely entirely on this. Even if we put temperature to 0, set everything, don't be creative, be precise. No, we cannot rely on that. It's non-deterministic, period. So, why I'm telling you that? Because it's the same. Building a plan normally works. Hopefully this will be more and more reliable, but so far we have to deal with these moving pieces. We don't know exactly. We cannot rely, we cannot put our life in the hands of AI yet, right? Okay, let's get into little details about function calling. What are function calling? What is function calling? Well, when we build prompts, because we are developers, we like our prompts to have parameters, to be dynamic, not static. We like to modify this at runtime, to drop in some arguments and to get different content depending on that argument. So what I'm telling, these functions are dealing with this dynamic behavior of a prompt. So what we can do, we can attach to our prompt some functions which we, as developers, are maintaining or developing, and then by using the semantic capability of the AI model, we expect AI model to figure out if we need, actually, if it's needed to call one of these functions or not. Again, this is not 100% sure, because sometimes the model decides not to call, but most of the times it calls. And the better prompts we have, the better chances to have this model calling our functions. So we concluded this. Function calling is having some user-defined functions which we attach to our prompts, send it to AI, AI figures out if it's the case to call them, sends back a JSON-packed construct, and normally, or if we look at lower level, we have to send back again to the model the prompt with the results of this function. So again, AI says, look, you should call this function. Try again. And then we know, oh, I call this function. Look, these are the values. Now give me again the response. And then eventually, if there are no more functions to figure out, the model will respond with a final response. So this is how it works. And this is built in. It's good because we don't have to improvise on the client side. Okay, so this feature was there months ago, months before Assistants. But then in November, if I'm not wrong, OpenAI released Assistants. And this was like an earthquake. Maybe a lot of startups were, oh, we are going to die. So because this Even semantic kernel used to have some planners which were built on client-side logic. But they were not needed anymore because OpenAI introduced assistants. And then these assistants are capable of doing the same thing, but more or less, but in the model. So, as I said, Assistants API was released, and this came with more features. So, we used to have those functions. They are called tools. So, if you look inside the JSON which is exchanged with the OpenAI models, you will find there like tools. They used to be function underscore calling, but they were rebranded tools. Anyway, these tools now are there in Assistants as well, but not only those, it's along with some more goodies. For example, you can attach to the message external files, PDFs, CSVs, source code. You can attach to your prompt these files. You can attach, I'm losing something, what else? So I said, okay, these tools have some special kind of, we can have special kind of tools like code interpreter or retrievals. But again, retrievals was rebranded in file search. So soon we will talk about file search, not retrievals. Anyway, the role is pretty much the same. Trying to bring in more data, more context for our prompts. And we know why we need that. It's for retrieval augmentation generation. And maybe for all of us, RAG, or retrieval augmentation generation, is synonym with vector database. But it's not necessarily. It can be an API to some JSON, XML, CSV, whatever. Doesn't need vector database. Only if the data is too large, then we would like to use this power, which a vector database brings in. Quick search, and so on. So with these new features, we can do more with the assistants. We can ground the assistants to some real-time data. How it works? Well, the main ingredients for an assistant are threads and runs. Let me tell you about a thread is a common context. So you are already familiar with what the context for a prompt is. But if you want to put some more instances, each of them talking with GPT to do something together, you have to manage the context because they have different context. Well, not to mention the fact that this is stateless. I mean, you send to the GPT, to the API, bring back the result, and you have to take care and then send back all the history again and again. And what happens? It grows. We are over internet, right? We are still having bandwidth, better or worse, but still it's a payload which we are going to send there. Well, Assistants API are coming with this concept called thread, which is keeping the context in the model, well, near the model, okay? But it's our context. It lives there until we decide to chat and until we finish the the session, but this context, it's common. So we can have more assistants, aka more GPTs, okay, which are sharing this context. Finally, they are talking together and we don't have to manage this on the client side. It's everything there. Of course, you can have access because we are acting from the client, of course, but it's still in server and the whole overhead, it's less. But how is this dealing with the token limits? Because there is no limit how many messages you can have. You can have any number, but still it's limited to the model context. And for latest GPT models, this is 128 kilos. Not very little, but still maybe not enough. So what happens if we have more context? Well, and this is the beauty of assistants, these assistants are getting rid of those messages automatically, which are not so relevant for the topic. And even more, if it's not enough, it summarizes and cleans up. Under the hood, everything is there. You don't have to take care. So virtually, you are not limited. But how it works? Well, we create an assistant and initialize a thread for that assistant. It's like everyone initiating a chat with someone. And then, depends who want to join the chat, they will keep adding messages into this thread. So the thread, it's our chat session. So we keep talking together and share the knowledge. And then, behind, these magical features are kicking in, like calling some tools, adding some context, interrogating some database, searching Bing, Google. And then they are assembling a response. Well, at the end, this is what we see, an aggregated response. But actually, it's a ping pong. Because, as I said, assistants have to resolve these tools. The model is detecting, oh, I need this, sending back a list. But still is the client who runs your code, Python or C# or Java. For example, I don't know, doing some logic in the deterministic way, traditional way. Then, after all these tools are having their response, then is what we see, an aggregated response coming back. But this comes with a cost, and it's not cheap. It's a lot of tokens. Hopefully this will get fixed in the future when the tokens will be cheaper and cheaper and cheaper. But this is now the trend. I heard somewhere 2024 will be the year for agents. Okay, I forgot. So, one trip to the model, solving this ping pong and coming with the aggregated response, it's called a run. This is a run. Now let's go back to semantic kernel. Semantic kernel can build agents which are not necessarily having assistants in them. It can be a simple prompt. Tell me a joke. Give me the response. That's an agent, but it's a very simple agent, right? And you can have planners, as I said before, solving a problem for you. And you can have personas. What is a persona? Well, nothing else than a GPT instance with a system message, or with the, and now I'm using synonyms, system message, meta prompt, instructions, all describing the same thing, the behavior of your prompt. But it's more powerful than the regular prompts which you are sending later, because it's the behavior, the persona of the agent. So, okay, having this, of course, today I will focus on assistants, the heaviest kind of agent. And for that I have prepared, let me see what you see here. Okay. I have prepared some agents. What do we have here? We have some historical or fictional characters. Yeah. And a special kind of agent, which is a script writer. Yeah, it's like the director of a movie. He's following the generating, he is dropping in the script, and the characters have to behave like in the script. They have some autonomy. They can improvise, right? Like they will do. So I'm planning to put these agents to work and let them generate some story. Or I will tell them the script, or maybe not, depending on the scenario. But this is what I'm going to do. I will tell you something funny here. When I run these instances, at some point, Yoda told to Jack Sparrow that Jack Sparrow is a fictional character. Look how this script can look. It's a list of prompts. I'm going to drop these prompts or user messages and send them to the model. I have a chat history and I want to see what happens. But I will focus on something very specific, and I will let the agents behave like expected. I don't have to work much on these agents because they are there in GPT. GPT was trained with stories about these characters. I don't have to do much, but let me show you. Okay, I will change a little bit the. I want to do that to duplicate my display, and now I will talk from memory. But hopefully I will not miss the point. You see the screen now, right?
Could you make it a light scene?
To make it how? Oh yeah, if it's better for visibility, definitely. Yeah. I don't know it, so help me. And especially when I'm here, I don't find anything.
Top right. Maybe blue or something like that. So it's good.
Or extra contrast. Let's try.
Yeah.
Looks good?
Perfect. Thank you.
Great, thank you. Let me show you a little bit how one of these agents look inside, or assistants, right? So this is the behavior. You are Jack Sparrow, talking Jack Sparrow style, and then I'm putting some constraints. Do not respond in more than 10 words, because I don't want these agents to be very chatty. But they have to provide a response to the last message. So what I did here, I put a very specific detail, and I declared, oh, Don Quixote likes Coca-Cola. Why I'm doing that? Because I want to see if some of other agents are reasoning correctly and they notice this detail and they respond accordingly. I want to see they say something about Coca-Cola. No advertising here, but can be anything. And of course, then I'm trying to exchange the acting agent with the passive one and see if the semantic, if the model senses this semantic role. But let's run this. I put everything in an API because it's easier to organize. No other reason. So let's try this, one of these approaches, but let me first tell you how we can put these agents to work, how they can interact. So I have declared these agents. I have created a thread, and then I should not forget to delete the agents because they are resources. But first, what we are planning to interact with these agents, we are, in the left is the user. And then we talk with the dialog writer. And the dialog writer is putting these agents to work. He will aggregate the response, send back. So we have like a project manager here, right? We are not talking directly with these characters. We are talking only with the dialog writer. This is one scenario. We have more. And let's go back to the hierarchical scenario, and I will drop in some script steps. Yeah, let me show you. They are pretty much the same. So this is our scripts. For example, these guys are having a feast, and Don Quixote likes Coca-Cola, all are making remarks about their favorite drinks. But then Jack Sparrow makes a bad joke about Don Quixote's tasting drinks. And Jack Sparrow gets a threat from Don Quixote, and then this guy is launching a fake attack. Shakespeare sends strong words to Jack Sparrow, but Jack Sparrow answers bravely and provocatively. So on. At the end, Yoda cleans everything up by sending a burst to Jack Sparrow dies, and so on. But this is a decent script, right? Let's see what happens. Execute. Meanwhile, this script will run. I will make it larger here. What I want to tell you, this is, I created the script, but nothing stops us to ask for a prompt and do it real time, to change the script real time. Yeah, let's wait a little. It's pretty lazy. If it's not responding decently, then have some screenshots. But here in gray, I have the first line of script. And now I sent this to the model, and the model will notice, oh, there are some guys by name. Yeah, Jack Sparrow agent, Jack Sparrow in script, and they are doing mix and match. So first response, first round, right? Because it's, they are all here, Jack Sparrow. Oh, everyone is here, so everyone has the chance to respond. Of course, Jack Sparrow says, my favorite drink is rum. Shakespeare's ale. Look, Coca-Cola is my choice, says Don Quixote. Of course, Yoda prefers tea. But then, bad joke. Don Quixote prefers Coca-Cola. That's almost as amusing as mistaking. Look, we can keep it like this for all day. You will see different kind of interactions. Some of them are not very nice, I mean not very fruitful, but some of them are really funny. And at the end, someone will die, because this is what I put in script. Do you notice this log here in danger? What is this? Well, for the sake of exemplifying how these tools can be attached to the assistant, I put a native plugin which has some C# alert which is writing in logs. And this alert is a tool which reacts because the model senses, oh, I had to call this assistant, but this assistant has its own plugin. And this plugin says if someone talks aggressively, then it's a danger somewhere. And I'm raising this alert. It makes sense? That's like an appendix to our assistant. But in the same time, we can do something more useful. For example, to call a text-to-speech, put them to speak. Or I can move, I don't know, maybe it's a robot. I can make it move somehow. So we can trigger things. This is what I'm saying. So these are going to conversate here until, how long? Well, until the script is done, because it's a for each, and I'm going through all of them. I let them run, but then I will continue with the presentation, because my time is, how many minutes do we have? 10 minutes, kind of, more or less? Okay, I'll try to, just tell me. Okay, so this is a diagram. In the left side, we have this agent, which has more agents. They are attached to the dialog writer agent as plugins. This is the way we are doing or building this hierarchy. We can imagine any kind of complexity of this hierarchy, but the more complex it gets, the harder it will be to create good prompts, good descriptions, behaviors. Perfect, thank you. So then we drop in the script entries, the script prompts. And then the prompt goes to the model. It sees the models as assistants. And then it's this ping pong solving some more tools. If it's the case, not so much in my demo, but if it's the case, it goes back and exchanges something under the hood. And then it aggregates a response and it's sending back. But let's check again. You know already, when we talk with GPT, we have different kind of roles. Any message has its own role. So these behaviors or meta prompts or instructions are having the role system. And then any other question we send to the model is having the role user. And any response which comes back from the model has the role assistant. These are three, but these are not all of them. When this ping pong happens between assistant and client, there's another role, and it's called, if I'm not wrong, tool something. I'm missing now the precise name, but it's another role, it's a special role. Okay, I have here an example, and let's see another kind of agent interaction. It's joint chat. This is not hierarchical, but it's linear. Everyone can talk with everyone. Even the user can talk with any agent. And in this respect, we will not send the prompt to the dialog writer. Instead of that, we will send the prompt like a roundtable to any of these agents. What do you have to tell? But what do you have to tell? What do you have to tell? So the same prompt goes to any actor. So we have, of course, this is not pretty much like a drama play will go, but it's good for collaboration, for scenarios where we try to solve a problem until the goal is fulfilled. And then we can put them to work, again, following a script, or maybe checking if a goal is fulfilled or not. If we have a script, we prefer for each. But if we have a goal to fulfill, maybe it's do while better approach. Pretty similar here, but look, now this agent, which used to be the script writer, now it has a secondary role. It's a narrator or whatever. It's just observing what happens there. Because I didn't want to remove it completely. I want to show you all these agents are still there. They are all contributing directly to the thread, which is the common context. The dialog scripts are dropping in, but every agent has the chance to answer. That's it 5 times, because everyone sends a request. But then the response is processed. If it's any tool, it will be called, and then the response is sent back. Let's see how this works. I will not run it because it's not very different, except it will give the chance to every single agent in the same specific order to respond. Instead of that, I have a screenshot. Pretty much the same, but look, 1, 2, 3, 4, 5, 1, 2, 3, 4. Everyone has the chance to respond. In the previous scenario, it responds only they are there by the name. So if Jack Sparrow asks Don Quixote something, then it's only Don Quixote who's responding. Oh, actually, it's Jack Sparrow asking, Don Quixote responding. So both of them. But not necessarily the other one will not intervene because they were not invoked. Nothing says in the script about the other two to say something. But here, it's another scenario, another approach. As I said, not so much for a TV show or a drama, a play. So now we go back to another kind of joint interaction, and that's I prepared here. Let me show you. Change it. Do while. I want them to put to work to solve a problem, and what I have here, it's these guys are starting a debate about their best drink, about the best drink in the world. Each of them is trying to convince the others for the preferred drink. Soon, some of them are getting convinced and they are starting to support the new drink. So it's a debate, but like people, they can change their preferences. And let's take a look on this kind of agent. For example, Jack Sparrow. Well, not very different like before, but let me show you what is the moderator, the debating moderator saying. I'm declaring now, because this is the central piece. You are a debate moderator. Evaluate the last 4 messages in the context. If a drink appears more than once, then that drink is the winner. How do we know? Well, we make it respond with cheers. And maybe the name of the winning drink. Why not? So if there is no winning drink, respond with the dot. So let's see how this works. Where is it? Joint, not this one, by joint, do while. And let's see another live performance. So they are starting to debate. Jack Sparrow, rum, of course, rum. Tea comes in. What else? Ale, fair enough. And wine. Who's gonna win? Any bet? I can guess, but I got all of them at some extent. I mean, I can let this work because this can go one round. Sometimes from the beginning, somebody says, oh, rum, like Jack. And then rum wins because it's more than once. Oh, complete? Wine? Look, so in round 2, Jack, it's rum, water, why not? Good wine, and Shakespeare and Don Quixote, wine, good. Wine wins. You want me to run again? No? Too late. But it's funny, look, it was a pain to fine-tune the prompt to detect when to respond cheers and when not. But at the end, it's possible. But as I said, you have to build good prompts. So what we have here, nothing. Look, it says nothing about what it's wonderful. Sometimes it's not wine. It's the grapes elixir. So it's semantic. It knows it's wine. It counts in this, and when it's counting, it's adding to the total. So what do we have here? Something to brew. Look, this rum. Finally, rum. Sometimes it goes like 10 rounds and nothing. And of course, there is the dark side of this. Talking about your dark side. It is a dark side. Sometimes they are getting corrupt. Slowly, they are starting to talk alike. So it's like people. If you stay too much and use the same language, somehow you are getting accustomed and using the same word, expression, and so on. These are doing pretty easy. After like 10 rounds, they are kind of just repeating themselves. And I mean, you don't notice, oh, this is Yoda only because it talks like Yoda, or this is Jack Sparrow. They are kind of talking the same. Anyway, let's this run, because why not? And let me tell you something. All the time we have here more agents collaborating, but can we send one prompt, put all the script in there in like a list, and get a response at once? I tried this with GPT 3.5. Don't try. It's not good enough. It's a pain. And it's very confusing, because 1 in 10 times it works. And then you run again. You know how we are doing. Change a little bit here, run again. Oh, it doesn't work. Switch back, it doesn't work either. So you are getting crazy. So don't try 3.5. Try 4. 4 Turbo, even better. What happens here? Oh, look, Jack Sparrow responded twice, because why not? It's an assistant. AI decided it has 2 things to say. And we can expect if he should have responded ram 2 of them, it counts in. But nevertheless, look, it's they are not winning yet. When I'm building these assistants, how much time do I spend building these? As much as I see a decent result. But if you're planning to do something performant, you have to spend more. You have to be very concise and clear in your intention. You have to use prompt engineering. By the way, if you ask for the response in JSON format, it simply works better. I don't know exactly why. I have a clue. Okay, these guys are not going to finish today. Nevertheless, we have to go. Let's run one more instance of this, and then we are kind of done. So I have not this one. All agents is one. So all the script, it's one prompt. A lot of names are mentioned there, right? All these assistants here and there in multiple lines. The response will get maybe a minute to be assembled, depending on OpenAI. And then the response will come as a list of JSON. I will not keep you waiting because I have a picture here. Yeah, so look, one prompt, dialog script, one prompt only. And then everything gets resolved, aggregated, and here is a response. So what we have here, it's a JSON with all the responses, pretty much following the script, sometimes better, sometimes worse. In the meantime, a tool was detected and triggered. Conclusions. OpenAI assistants are still in beta on Azure, but they are out of beta on OpenAI API. That's a good news. Maybe they made them better. I hope so. But these agents are the future because we don't want AI only to send some prompts. We want AI to solve real-life problems and to collaborate. And it's good we can specialize instances to make one assistant is scientist, the other one is economist, the other one is project manager to aggregate, and so on. And every assistant is specialized in bringing back some other kind of response, focusing on some other things, other pieces, but not only that. Each assistant can have his own tool set. You can have up to, I don't know, more than 100 tools attached to one assistant, and 20 files with megabytes. Anyway, it's very good. We can build complex assistants, but I'm not telling it's easy. What I wanted to exemplify in this material was the way we can put these assistants to work. We can be even more inventive. But yeah, I hope you liked it. And yeah, let's enjoy the rest of the talks today. Thank you.
Are there any questions?
Sure.
Am I just supposed to speak into this? Hello? Maybe that's a bit of a weird question, but why was it so slow?
Let's ask OpenAI. But it's...
Yeah, but like I know that I know that AI things and prompts are streamed, you know, because if you it just streams it and it's quite slow, but this seemed to be very, very slow. Is there any reason for that?
Yeah, assistants are very chatty behind under the trunk. They are communicating a lot. We don't see what happens there, but it's a lot of interaction. Yeah. They are putting a lot of messages in thread. In the end, we send maybe a prompt, but there, depending on how many assistants are involved and how many tools they are triggering, we may have dozens of discussions with the model. And it's not only that, because it was not streaming anyway here, and I'm afraid Semantic Kernel is not supporting the streaming yet, but it will be in the future because it's there in OpenAI. As I said, it's at the beginning, it's the other piece which is the laziness. sometimes they are not responding. The model is not responding at all, not very often. But I encountered this too. So it is slow, maybe even because my account is not quite free, but it's maybe it depends on this what kind of subscription do you have, and so on. But it is slow for now.
Yeah.
Hopefully this will get better and better because it's very useful.
Okay. Anyone
Thank
else?
you.
Can I throw a cube at someone?
Maybe me?
Yeah.
Well, thanks for the presentation. I would like to repeat these examples that you have here at home. What do I need for this? And maybe you have shared the presentation and the code somewhere on GitHub.
Yeah, I have it in GitHub. It was on the last slide.
Okay.
It's on recording. Yeah. It's on the last slide. It's a GitHub repository for this. I will update it with the latest version. But what do you have? Only an OpenAI subscription. Either is an OpenAI API or is in Azure. You have to have this subscription, a key for your account to work with OpenAI. This is everything you need.
Is it paid or something?
For example, because this is immediately if you pay, but yeah, I will not lie you. It's expensive because assistants are very chatty. For example, until I stabilized everything, like in 2 days, I spent $20. Real money, not virtual. But then I decided, okay, I will play with 3.5, GPT 3.5, and because it's about 10 times cheaper. And then when I have to do some better tests, I will switch to 4. Nevertheless, since then, OpenAI decreased the price 3 times. So it is expensive, but not very expensive. And it will get cheaper with time.
Yeah. Thank you.
In time.